Hi guys, are you guys ready for Christmas? Look at my Christmas tree. Isn't it great? But look at these beautiful silver test tubes. Don't you guys want to make this? Let's go to my lab and make it using chemistry, and there will be magic along the way as well.
Hi everybody.
Now, let's make this glass tube into a silver chemistry ornament. It may sound weird, but it is possible.
Are you kidding?
No, I'm not kidding. It is possible.
Oh.
All you need is 1 gram of sodium hydroxide, a fraction of a gram of glucose, a gram of
sugar.
silver nitrate. Yes, glucose is in fact sugar. And last but not least, 3.5 milliliters of concentrated ammonia. Now, if you're doing this inside, do this with well ventilation. Ammonia smell is very foul. First off, let's dissolve our 1 gram of silver nitrate into about 50 milliliters of water. The idea here is to make a 1 molar solution of silver nitrate. So now I have this foggy solution of silver nitrate. Why it is foggy is because some of the silver tends to become silver metal. So we're gonna have to filter the silver nitrate out. Mushi, do you see that clear solution coming through?
Yes.
It's all silver nitrate. Silver nitrate's alternative name is lunar caustic because it can cause severe skin burns, and ancient alchemists used to link silver to the moon.
And why we're wearing it in shorts then?
No idea. I should really invest in a lab coat soon. Now, we have a very clear solution of silver nitrate. See here?
We're gonna put it in this beaker.
No, this beaker first. Remember, silver nitrate is only one ingredient in the Tollens reagent. We still need 3 more ingredients to go.
I thought we need
Now-
only one ingredient.
No. For the silvering solution, you need 1 gram of silver nitrate in about 50 milliliters of water. Next, the part we dislike the most, ammonium hydroxide. The odor is very foul, so get some well ventilation here. But the good news is, we're gonna do some magic. So let me get my pipette. Okay everybody, ready for some magic? Let me just bring this stuff closer. Oh, the smell. It is very foul. That is the worst smell I have in my lab since the beginning, right, Mush?
I can't smell anything.
Oh, you better. So let me just put that wrap back on. The odor is so foul. Fine, oh my. Now we just add it to our silvering solution. Ready everybody? No brown.
Now what? We're trapped in here forever.
Oh my gosh, the smell.
It's the smell.
Wow.
It's gone now.
Did you see it everybody? The very foggy solution became clear.
What happened?
This is because ammonia has a tendency This is because ammonia has a tendency to form complexes with heavy metals, in our case silver. Okay, now for our last ingredient, 1 gram of sodium hydroxide. After adding that 3.5 mils of ammonium hydroxide, we add the gram of Hydroxide.
What is it?
Sodium hydroxide.
And we're putting it now.
No, not now. You can see that black stuff is forming here, which is all silver oxide again. However, due to the excess ammonia, the silver will now dissolve into solution again.
Why is it all yellow?
Oh, the yellowness? This is because Tollens reagent discolors and forms something known as silver nitride, Ag3N. Now that our Tollens reagent is prepared, let's do our second part of the very fantastic magic. It is this yellow solution first turning brown, and then black, and then finally silver. Ready, people? And it will only take about a minute or two for the mirror to form. Now let's fill up our glass tube, which will soon become our ornament.
I thought that was a mirror, not an ornament.
Oh, it's more like half and half.
You drained some. You spilled some.
It's okay. Then you just seal it on.
Now shake it.
No, don't shake it.
It's not getting darker now, though.
Well, it's becoming brown, right? Brown?
No, not really. It's coming down. It's going brown.
Yes.
Almost.
And then now it's becoming black.
Yeah.
From the bottom up.
No, it's darker and darker and darker.
Soon, our ornament shall be finished. Are you happy, Mushy?
Yes. The darkness must be calmed.
And then our dark solution will become beautiful silver.
How do you know?
Nah. We'll see it in the explanation, but I'll just tell you. Glucose is something called a carbohydrate, so it contains an aldehyde group. The aldehyde is oxidized to carboxylic acid, while the silver ions are reduced to silver metal. Now note the fact that the ornament must be made of glass. It will precipitate onto plastic, but not that well. On glass, however, it precipitates very well.
Do you believe it? Black turning to silver.
I think we might be getting a little silver now.
There's nothing silvery.
Yeah, it should take about a minute or two, so be patient. Some reactions require patience. Did you like our Christmas magic?
Ho ho! Ooh, shh.
I bet he did. Now, let's put our ornament onto our tree and see you in the explanation.
Bye.
Now, let's see how the mirror formed. But before the reaction, let's see the aldehyde oxidation and reduction. This is our glucose. Glucose's chemical formula is C6H12O6. C6H12O6. Now you might be wondering, well, where are all the carbons and hydrogens? Well, in organic chemistry, they just draw it like this, where these joints are all carbons and all of the other ones are hydrogens. For example, this guy, Carbon requires 4 bonds, so 1, 2. Because there are only 2, the other 2 right here should be hydrogens. They just don't show that because it gets really messy when you add the hydrogens in. In our experiment, the glucose was oxidized to something called gluconic acid. Gluconic acid is actually the key to many calcium, potassium, and other supplements in their gluconate salts. Gluconic acid is something called a carboxylic acid with the COOH group. COOH should be familiar to you because in our second video, we talked about acetic acid, which is CH3COOH. Both of them share the COOH. Now, here I have this chart here. Carboxylic acid, which is something COOH. Now, before that, R means remainder of the molecule, meaning that it's a carbon chain. Is reduced to an aldehyde, CHO. And then it can be further reduced to a primary alcohol. Primary alcohols are just alcohols, but here the carbon has bonded to 2 hydrogens, 1 oxygen, well, more like 1 hydroxy group, and the R group. Why it is important to say it's a primary alcohol is because other alcohols oxidize differently. For example, secondary alcohols like say isopropanol oxidize to form ketones, which are different from aldehydes. So isopropanol will oxidize to form ketones, in our case acetone. However, secondary alcohols only oxidize one time. Also, there's a third one called tertiary alcohols. For example, if I take tert-butanol, along with other tertiary alcohols, do not oxidize unless you break at least one of these carbon-carbon bonds. So it is important that you say primary alcohols oxidize the aldehydes, which oxidize the carboxylic acids. Now let's look at our reaction and equation. First off is our first magic, silver nitrate and ammonium hydroxide. The two react to form silver oxide, water, and ammonium nitrate. Now you might be wondering, well, shouldn't it be silver hydroxide? Well, as far as I know, silver is one of those few metals who don't have hydroxides. They only have oxides. So when silver hydroxide is present, it immediately reacts with itself to produce silver oxide and water. Silver oxide, like almost all metal oxides, are insoluble in water, so it became this cloud, which is actually brown. However, let's look at the reaction of silver oxide and excess ammonia. The excess ammonia will react with the silver oxide and produce 3 water molecules along with something known as silver amine. Silver amine is a complex between silver and ammonia. Why this forms is hidden in ammonia's structure. In ammonia's structure, here I put 2 little dots. This means that ammonia has something called 2 electron pairs, because nitrogen follows the octet rule, so it has 8 electrons. 2, 2, 2, and 2. This electron pair is easily shared with other atoms such as silver ions and protons. So ammonia is a base and it forms complexes of many different metal ions. Okay, so now that we have our silver amine, now it reacts with our glucose in our tube. The silver amine complex reacts with the glucose and sodium hydroxide. The first reaction is silver being reduced and into silver metal, ammonia, and 1 water, not 2 yet. Now, the other water, making 2, is from the acid-base reaction. Glucose, as I've said from the start, right here, formed the gluconic acid. Gluconic acid is an acid, and sodium hydroxide is a base, so the 2 react and form sodium gluconate. Now, if you want to keep your tube, you can always get some acid. For example, nitric acid. Silver reacts with the nitric acid to form silver nitrate, water, and nitrogen dioxide. The acid is preferably concentrated so that it reacts better. However, other acids can do the same thing, such as perchloric acid, which is much stronger, and glacial acetic acid. Now you might be dazzled by the fact that acetic acid can dissolve silver. Well, only in high concentrations though, since normal vinegar can't dissolve even copper. Thanks for watching, Merry Christmas, and a Happy New Year. Bye!